big is the universe? The answer is unfathomably huge. It is even hard to represent the universe to scale because you will quickly run out of space. However, as sheer as the size of the universe is, it is full of mysteries. One of such huge secrets is a structure at the edge of the universe just discovered by NASA. This structure is a big deal because it affects you despite being so far away. What is this mysterious structure, and how does it affect you on Earth? Join us as we explore the mysterious structure near the edge of the universe found by NASA. The word universe comes from the Latin word universus, meaning whole. So a question like, what is the size of the whole universe, basically is asking, what is the size of whole? On a more serious note, however, how large is the universe? As we attempt to answer the question, bear in mind that there is a significant difference between the universe and the observable universe. Let's start with objects closer to the Earth. NASA plans to resume regular missions to the Moon, but how close is it to us? Moonbound astronauts will spend 3 days en route. However, Elon Musk's Mars colonizers will spend more time traveling through space because the shortest length of time is 5 months. If they're willing to spend 15 months traveling, they can touch down on Venus, but going to Jupiter will cost them 6 years of their lives. However, if their focus is on the farthest planet from us, Neptune, that will take a solid 12 years. Traveling within our solar system takes long, but that hardly prepares you for the size of the universe, which has been estimated to be 93 billion light-years across. But that is not even the most astounding part, which we will get to. However, let's try to understand just how large the universe is first. We will use the Sun, the center of our solar system, to make sense of this. Thanks to the Sun, our Earth remains in orbit. However, this star is nowhere near us. The Sun is 1 astronomical unit AU away from us. 1 astronomical unit is about 150 million kilometers or 93 million miles. Now, the universe is 93 billion light-years across, and just one light-year is equivalent to 63,000 astronomical units. As such, 1 light-year is the equivalent of 9 trillion kilometers or 6 trillion miles, and our universe is 93 billion light-years in diameter. That's how big our universe is, and that's not even the end of it. The 93 billion years is just the observable universe, the universe which we can currently see. The whole universe might very well be 250 times larger than the observable universe, or at least 7 trillion light-years in diameter. If the universe is so huge, how old is it? How long has it existed for it to be so big? That is another mind-boggling fact because it is estimated at 13.8 billion years. How do scientists work out the age of the universe? Well, the universe cannot be younger than its oldest stars, so one method is to measure the ages of the very first stars that formed in the cosmos. The life cycle of a star depends on its mass, with high-mass stars burning fuel at a faster rate and therefore dying out faster, while low-mass stars can live up to 20 billion years. Globular clusters are a dense stellar collection of around 1 million stars which all formed roughly around the same time. These clusters can then serve as timekeepers for the universe. By determining the masses of their stars, scientists can estimate when the globular clusters formed. The oldest globular clusters contain stars that are 0.7 times less massive than the Sun, which suggests that they are between 11 to 18 billion years old. But then, why is the universe so big? The universe is so big because it is constantly expanding, and it does so at a speed that even exceeds the speed of light. Space itself is actually growing, and this has been going on for around 14 billion years or so. In this amount of time, with a speed greater than the speed of light, the universe gradually grew and still expands even to this day. This brings us to the subject of the observable universe. How big is the observable universe compared to the whole universe? Because of the connection between distance and the speed of light, scientists can look at a region of space that lies 13.8 billion light-years away. Like a ship in the empty ocean, astronomers on Earth can turn their telescopes to peer 13.8 billion light-years in every direction, which puts Earth inside of an observable sphere with a radius of 13.8 billion light-years. The word observable is critical. The globe limits what scientists can see, but not what is there. But though the sphere appears almost 28 billion light-years in diameter, it is far larger. Scientists know that the universe is expanding. Thus, while scientists might see a spot that lay 13.8 billion light-years from Earth at the time of the Big Bang, the universe has continued to expand over its lifetime. If inflation occurred at a constant rate through the life of the universe, that same spot is 46 billion light-years away today, making the diameter of the observable universe a sphere around 93 billion light-years, as stated earlier. Knowing the size of the universe is not enough though, because what about the shape of the universe? There used to be disagreement about the shape of the Earth, but that has been largely settled because we have photos of the Earth from space. However, the form of the universe is not so simple. The size of the universe depends a great deal on its shape, and scientists have predicted the possibility that the universe might be closed like a sphere, infinite and negatively curved like a saddle, or flat and endless. A finite universe has a finite size that can be measured. This would be the case in a closed spherical universe. But an infinite universe has no size by definition. According to NASA, scientists know that the universe is flat with only about a 0.4% margin of error, and that could change our understanding of just how big the universe is. However, NASA admits we can only observe a finite volume of the universe. This brings us to what is the largest object in the universe? How large is the largest thing? It is so large that it is not supposed to exist. This is because it transcends our perception of size and violates the very laws of physics. The structure is the Hercules Corona Borealis Great Wall. Cosmologists have always been baffled by the uniformity or homogeneity of the universe because the leftover heat from the Big Bang is astonishingly uniform in every direction we look. And because these early temperature fluctuations subsequently led to density fluctuations, one can also say the same thing about the matter in the universe. If the matter in the universe wasn't so smooth and uniformly distributed, large clumps would have attracted smaller chunks of matter, and the universe wouldn't have expanded but instead contracted under its own gravity. However, even though it is homogeneous on a very large scale, the universe, due to slight initial irregularities, is locally heterogeneous. The heterogeneity can be observed in dense populations of stars, galaxies, clusters, a collection of galaxies, and superclusters, a collection of clusters. The homogeneity was explained by the theory of inflation, a highly crucial aspect of the Big Bang model of the universe. This model is currently believed to be the most convincing explanation of the birth of our universe. However, the Hercules Corona Borealis Great Wall is a supercluster that represents such an immense irregularity or non-uniformity that it defies the laws of inflation. The supercluster is so humongous that it exceeds the maximum structural size allowed by the inflationary model of the universe. The Hercules Corona Borealis Great Wall was discovered in 2013 by a team of astronomers while looking for gamma-ray bursts, or GRBs. For this reason, the structure is often called the Great GRB Wall. Gamma rays are the most powerful type of radiation in the entire electromagnetic spectrum. Such super-high-frequency radiation emanates only in a handful of stellar events, such as supernovae, the explosive death of a star, collisions of neutron stars, or matter spun around violently by a black hole. The energy released during a supernova is so colossal that the Sun cannot produce the same amount during its entire lifetime. Astronomers study these bursts because they enable us to locate massive structures in the universe. Massive stars can only form around a dense surplus of mass because that is what they feed on. Also, planetary systems like our solar system are fundamentally congregated debris dispersed during the explosive deaths of these very same stars from supernovae, so studying these structures allows us to glimpse both the childhood and the grand history of our universe. So these researchers recorded an unusually high volume of gamma-ray bursts concentrated about 10 billion light-years away in the direction of the Hercules and Corona Borealis constellations. The angle this volume spanned in space translated to a width of 10 billion light-years. Yes, the Great GRB Wall is 10 billion light-years wide. For perspective, that is 10% of the diameter of the observable universe. The researchers themselves were skeptical about their discovery. How could a single structure account for 10% of the whole observable universe? Co-author John Hackler expressed his disbelief in a press conference in 2014 when he remarked, "I would have thought this structure was too big to exist." However, the team calculated that the chances of the gamma-ray shower springing up randomly in that location are very slim, in fact, far less than 1 in 100. This brought them solace and convinced Hackler to believe that the structure exists. In fact, other structures appear to violate the inflationary model, such as the Sloan Great Wall and the Huge Large Quasar Group. This is why Hackler is adamant that the hype of the Hercules Corona Borealis Great Wall being the largest object won't last for long, because sooner or later, someone is likely to come along and find something bigger, more distant, or older than the thing you found. So fingers crossed for other mysteries that could spring up from the edge of the observable universe. Let's hear what you think of the biggest object in the universe in the comment section below.